So, everybody had their coffee? Super caffeinated, super excited? So, we are super organized here, and Dong and I both intentionally submitted talks, coordinating closely, of course, that happen to be very similar, and they immediately follow one another. And of course, that was entirely deliberate, wasn't it, Dong? We didn't find out about that at the 11th hour, right? So Dong's going to get to kind of the ARM story, the ARM end of this, and I think talk through the actual implementation of the specs and so on. What I wanted to do was what the current landscape of standards addresses for folks like me who still use VGA, and then really just get some feedback from folks here about where they see they want the ARM server standardization effort to go, or tell me where to go. So you know who I am, that annoying guy, right? So let me give you a quick overview of the existing standards that we have on ARM server. I want to walk through a little bit the goals we had. It's not me lecturing. I'm going to give you about 5 minutes worth of talking, and then I'm going to shut up and let people actually speak. So, I'll walk through kind of some of the goals we had, and then two of the documents that exist today. The SBSA that people have heard of, I think, and then the slightly lesser known document, the SBBR, which sometimes gets referred to at the same time as SBSA, as if it's one and the same. So, what were the goals? Well, in the server space, it's kind of an inverse situation from what you have in embedded, right? So on an embedded platform, what you do is you have some impossible deadline to ship some new widget. You go and build some wonderful gadget everyone's going to buy this holiday season. And then you have to go and modify the OS in some way to provide device drivers, to provide support for the hardware that you just made. In the server space, in the enterprise space, we still use VGA, and the operating system you're going to run next year was already made last year, right? That's the key difference. So in fact, the lesson that a lot of the people building servers have learned time and time again is that it's easier to change the hardware than the operating system, right? It's a little bit of an exaggeration, but there's a lot of truth to that. And that's an inverse from the mindset a lot of people have going in, especially if they come from an embedded background. We had a lot of interesting use cases that we wanted to address. We wanted to have a lot of flexibility, but we wanted to be able to build binary operating systems, open source, free software operating systems in my case, but binary builds, one size fits all if you like, that you can take this single OS image and you can run it on a whole family of different machines. And we wanted to have flexibility to implement, yes, the kind of features that people see on x86 machines. So if you are a server vendor today, you're very familiar with concepts like firmware first error handling and complex platform firmware. So if something happens, it's not the case that Linux is the first thing that hears about it. In many cases, Linux may be one of the last things that hears about an event that occurs. So there's two documents that we worked on. One is the server-based system architecture. And you can think of this as the hardware spec. So the SBSA defines certain minimal architectural features. At the time, it was ARM 8.0. Of course, David yesterday was talking about much later revisions of the ARM architecture. So the ARM V8 architecture, the 64-bit architecture, evolves over time. There has been an 8.1 release, there has been an 8.2 release. You can imagine that numbers increase monotonically in a forward progression, and that there may be other numbers that come after 8.2, 8.3, and maybe even higher numbers than that. I don't know, Charles. Is there a number after that? I don't know, right? Maybe, right? So something could happen. And so what we wanted to do was to say, this is going to move forward. How can we address that? So we came up with a common minimal set of features. We had some interesting ones. So when I say PEs, that should be capital P, capital E, but LibreOffice is being wonderful and correcting me there. It's processing elements in ARM parlance. We had some controversies in the early days. So some of the early, one of the early ARM v8 designs did not implement what is called EL3, or the secure execution state that exists on ARM machines. And if you like, that's a different execution context. On x86, you have something called SMM, or system management mode, that a lot of people hate. And it's where a lot of platform gunk is hidden. So one thing we did was seek to get everybody to make sure that was implemented, and these areas where you want to implement these capabilities on servers were there. We defined certain minimal SOC features: interrupts, clocks, timers, power on, power off. We had a lot of wonderful conversations about UARTs. I remember many hours of conversations around, wouldn't it be great if we had one UART type? We have two, but that's pretty good, given the ARM space. And I'm not getting that hair back, so that's good. Over time, we've added some extra pieces. So for example, if you're doing I/O virtualization, the spec provides some guidance. But it's very generic. It doesn't say, if you do I/O virtualization, you will implement SMMUs, which is the ARM term for an I/O MMU. You will do it this way. You will do it exactly in this topology. That's not how ARM is. So you can think of this spec as minimally prescriptive, but not necessarily entirely sufficient by itself. And then we have a document called the server-based boot requirements, or the SBBR. That's the evil ACPI takeover of the world that everybody loves to hate, right? And it wasn't actually just, people like me being evil. We actually got a lot of different OS vendors together, and ODMs, and all kinds of people, and we said, and not just Linux vendors, lots of other OS vendors. And we said, how would you like to boot and describe the hardware in these machines? And we had some spirited conversations about how that could be done. And ultimately, pragmatically, my perspective on it was, I don't care what we pick. There's many documents I've got saying that I prefer other technologies. 6 years ago, things I wrote that said, maybe device tree will be the great thing that we pick, and it will be wonderful. And so the goal was, let's pick something, and let's use that, right? And then we'll have flame wars about it. So what it does is it describes that you will use UEFI on a server, you will use ACPI, SMBIOS, and then some wording around how you boot the machine. And we had two ways of booting machines early on, because one's never enough. We had a very early mechanism that was used on machines that couldn't implement what is PSCI on ARM. It's a nice generic way of turning machines on and off. But then very quickly we standardized, right? So sometimes we can't do what we want on day one, but on day two we can. And what these standards do is enable minimal APIs for installation, runtime, things of that nature. So what they do cover today are a minimal set of standardized hardware and operations, right? So as an example, I love to give the UART example because we spent many hours on that one. The spec says things like, if you access unpopulated memory, it will eventually complete or not complete, but something will happen. We won't just get into some infinite state and never come back, right? Because it'd be nice if you did something. And you can boot into a standard OS bootloader, and you can get boot and runtime services, discover what hardware you have, and you can have certain abstractions for the way that the industry builds servers today, which is through very complex firmware and using mechanisms. So ACPI, for example, isn't just a way of describing hardware, right? ACPI also has this runtime environment called the ACPI machine language, which is a kind of bytecode that gets interpreted by an interpreter in the OS. And so when certain events happen, we actually interpret this code and we do things. And so when we do things, that might include, poking some memory location, and the side effect of poking that memory location is that we talk to some embedded microcontroller that changes some other state. And the cool thing is about that is that we don't have to modify every OS to understand on this platform you're going to poke this magic location to do this thing. Instead, we have certain abstract methods that say, turn this thing on, right? And how it gets turned on is not necessarily something the OS has to care about if you shipped that OS last year, right? So that's why things like ACPI are kind of very useful to us. What they don't cover, so there's some hardware features that the specs we have today don't cover. They don't cover some of the nuances of caching. There is no standard memory map on ARM servers. So, you know, in the early days, some of us had these naive assumptions that ARM servers would kind of act a lot like their x86 brethren, right? And I remember having many debates with people, you know, wouldn't it be great if we mapped the RAM at 0? That would make a lot of sense, because people have built a lot of software over the years where they do that. And people don't want to standardize some of these things. So, okay. But we've had a lot of learnings as a result of that, you know, there are operating system drivers, there are lots of assumptions built over many decades that, you know, DDR starts at 0. So we've had some learnings there. Things we never thought about, you know, I naively thought in the early days that PCI was PCI, right? And Charles is laughing, right? So, you know, we have, people criticized us for, you know, you say do SATA and things like that. We're a little bit more prescriptive than that, right? But we learned a lot, right? We learned that, you know, we have these quirks we've had to put into Linux because people's PCI implementations are not quite as wonderful as some of the long-standing IP that you've seen out there. And we're working on robustness, and we've learned lots of things, and we've made many adjustments. And then there's work to do, things that we never really thought about. We have some language around I/O virtualization, but it's not very prescriptive. I think that will change over time. And then we didn't cover a lot of emerging technologies. So some of the pieces required for a full NFV solution or hardware acceleration, these things were pieces that perhaps we didn't think about because we were trying to just get these machines booted, right? That's a lot of intro from me, and what I wanted to do was give you guys a chance to just throw ideas out there for things that you thought had worked, hadn't worked, or that we should consider going forward. And yes, please, go ahead. Yeah. Yeah. Yeah, we both have the same. Yeah. I'll repeat your question, by the way, for the recording. Yeah, go ahead. Go ahead. Yeah. Yeah, yeah, yeah. So I think we're very aligned in that thinking, right? So I mean, yeah, well, yeah. Sorry, yes. So the question is basically, in light of the fact that systems are shipping, we've already made the OS years ago that people want to run. SLES 11 in that case, you know, RHEL 7 in Red Hat's case, but you know, whatever, right? And people want to install that on newer machines. And today we have driver update disks. We actually have a very similar mechanism between, and intentionally so, between SLES and RHEL, for example. And everybody else has a similar thing at boot time on, Windows machines on x86. You press, I don't know, F8 or something and put a driver disk in, right? I think what we did going in, so then your question is really, should we have done more to standardize? Mm-hmm. Yes. So you want to see some means, for example, to update in a generic way, and I think that's a good idea, right? I think what we did going in, inject. Correct. Correct. Yes. Yes. Yeah, you're screwed. Right. Right. Yeah. Yeah. I think we're very aligned. So it's sort of could we do something better around driver updates that wouldn't require that you either emulated some floppy disk or provided an initramfs overlay or something like this. And I think what happened was when we built these specs, we thought about we have this x86 model. I'm being brutally blunt here. This is not necessarily ARM's motivation or anybody else's motivation. This is my motivation, right? Selfishly, we set up this ARM team. We have to get to a point where this is Red Hat story. We have to be able to one-day support RHEL on ARM servers. Oh dear God, it's not yet standardized. What can we do, right? So that was our mentality going in, was we better get all over this because we need to make sure that if ARM servers take off, which we think they will, playing the numbers forward in 5 years' time or 6 years' time, which is where we are now, we better get involved and we better make sure that business as usual will work for us, right? That's our selfish motivation, and I think we had similar selfish motivations, right? In a good way. But we didn't think about, I think, how to solve some of the problems in novel ways. We thought, how do you do it on x86 today? We better make sure at least that works, right? And I do think we have an opportunity now to say, we have all this stuff, but to your point about injection, I mean, I think it's the same thing for booting 10,000 servers or 100,000 servers. Today, we still have this idea that, you boot them, they all hammer the network, they all get, DHCP, or maybe they're IPv6 and they're a bit better, but, they all hammer the network and get some boot file and run over the network. And what we could do is standardize, for example, loading memory locations with, injecting files onto a server ahead of time and saying, just, I'm going to provide you with a bunch of stuff. Don't worry about how it got there. You can discover, capsules or however you do it, and load them. And I think that's something we could absolutely look at. Do you want to write that down, Charles? Injection of cool stuff. It's great, isn't it? Yeah. It could be a UEFI thing, yeah.
Right, because I mean, UEFI is our common interface. It is the best way, and you've got access to the same things that Red Hat's got access to.
Yeah.
And I would say that focusing on making sure the right stuff's in UEFI is the best way. Yeah. Right.
So let's capture that, because I think that's a good thing. But we've got just a couple more minutes. So what I want to do is,
well, that's the question: is how do you know? When do you know what you need?
right?
Because that's when you have to decide to get that file. But yes, take it off the table.
Yeah, let's write that down. Let's definitely take that away, because we had a 25, 30-minute maximum session. We may go over about 2 minutes, and we'll try to get them back to you. But let's get some other ideas, right? So anyone else got something else they want to throw out there? Things that we missed, we didn't do, you'd like to see? Do you want to answer that, Charles?
So far, in the way we've done things in the architecture, it has been a it has been a who you know. I'd love to say that. Okay, cool. I can't hear it. I'd love to say that, you know, there's like a nice process around this, but there isn't really. It's about, okay, we did set up the server AC, so there is a forum where all companies, the way we started these specs, we actually started with primarily the end of the spectrum, so OSVs and ODMs, OEMs, tried to understand what the server landscape was, and then gradually we brought in other vendors, and then we brought in silicon vendors at the end. So every silicon vendor in the room does have a contact with the architecture team. But we didn't have a formal process for defining actual requirements for the spec. As in, other than, you know, we met and we discussed it, and you know, the spec was then shared with people, and people could then, you know, evaluate it. But the reason I'm saying, mentioning the formal process thing is because we're actually considering introducing something. We're actually thinking of doing something that's a bit more analogous to the way, say, UEFI works, where people can actually submit a change and say, and part of the reason is because also there's a lot of emotion around this, and people say, oh, this doesn't do anything, it doesn't do this shit or that shit, but there's actually no detail in those statements, and what we need is an actual, no, what we really need is a change that would be like this, right? And so that's why we're thinking of considering introducing something.
It's also, I think you need to be nuanced there as well, that when we're talking about that, that's SBSA and SBBR, which there's also UEFI and ACPI. And one of the things that did happen very early on when we were discussing what the description mechanism was, ACPI or device tree, is settled on ACPI, but also came to the conclusion that ACPI is only going to be relevant for us if Linux people can have a proper seat at the table. And so there were major changes that were done in the way that ACPI was developed. ACPI was moved into UEFI.org, which is an open organization, and there's a proper process around defining what the next ACPI is, and an increasing cadence, so that the things that we need for ARM and the things we need for Linux are getting into ACPI.
By vendor, yeah. So I think just if I may, Charles, I think, or even if I may not, I mean, I'm going to speak anyway. You know me, right? So I think people want sometimes ARM to be. I'm not saying you. I'm saying in general. People want ARM to be so open and so transparent and so wonderful. But if you look at, say, x86, I'm going to pick on x86, right? It's really just, here's a bunch of stuff that Intel did, right, years ago, and that's how it's done, right? And when people say, why can't you just do this? Often it's, why don't you just do exactly what Intel did in some very closed, very cabalish-like environment? And to Charles's point, I think what we are trying to do is get to an open process, and we should change that. And I think sometimes we've discovered that we said we do.
I think maybe what's lacking is people knowing that, but actually the people are there, you know, and so it's about us putting out a bit more information as to how to ask these questions, which I completely agree with, but you know, but it is open to John's point.
Right, and we are looking at, for example, in the past we've had, you know, ARMS models which are, you know, not just open source, you can hack on them. We do have efforts going on in Linaro to have open QEMU references for, say, you know, enterprise platform references that say, here's how you should build something, here are all the pieces that go together, and then we can explore new ideas, and we can say, doesn't it make any sense when you actually implement it, right? So we've been playing catch up, and now we're at a point, I think, where we can take a step back and say, well, there are things that we should be doing differently, and that's definitely one of them, right? Yeah, and no one disagrees. Yeah, do you want to add something?
So I think some of this, stay in the room and listen to what Dong has to say, because I think some of what Dong's going to say is going to relate to this, but also we are looking this year to do some stuff about, system guidance, for want of a better. So there's system guidance already available on ARM for people who have SoCs or use compute subsystems, but also looking at just the more general, I'm building a system, what are best practices for laying down SMMU and GIC for virtualization, best practices for ACPI tables and things like that, and making that available, so making more information available.
Yeah. All right, so before we hand over to Dong, is going to go through kind of the next session. Anybody else want to throw something out there? Don't be shy. Now's a great time to throw things at us. So we'll look at open forums. We'll look at ways of making this much more democratic. Yeah, and just in fairness, we always wanted this to be open. I think there was a time there was a time when men were kind. No, there was a time when we first met. And I first met some of the guys in this room, and we used to have these code names for things that Arm was working on. And you'd say to somebody, "Do you know anything about magic code word here?" And they'd be like, "What do you know about that?" You know, and that's the sort of, there's a 64-bit Arm architecture, and that wasn't even public, right? So let alone people who were involved wanting to talk publicly. So I think now it's very different. But when we started this, it was very, very early.